So this video is about interpreting data. So the first thing is qualitative data, which is kind of like categories. So it deals with descriptions, data that can be observed but not measured. Some examples are colors, textures, tastes, smells, appearance, beauty, phone numbers, etc. So qualitative is quality. So examples how you display qualitative data would be a frequency table, a dot plot, a bar chart, or a pie chart. So the bar chart, notice how the bars are not touching. They don't touch. That's important because what we did yesterday with histograms, the bars do touch. So bar graph or a bar chart, they do not touch. With quantitative data, that deals with numbers, deals with quantity. So it's data that can be measured. Length, height, area, volume, weight, speed, time, temperature, humidity, cost, members, age, test scores, all of that deals with numbers. So you can look at it with a stem and leaf plot, a box and whisker plot, or a histogram like we did yesterday. And these two types of way are not the only way to display data. So it's not the only way. It's not the only way to display. So just know that you could see it other ways as well. These are just the most common ways to see them. So when you go down, it says, what's the difference between a bar chart and a histogram? So a bar chart is for qualitative data, and they do not touch. While a histogram is quantitative data, and the bars touch. So bar chart is qualitative, do not touch. Histogram is quantitative data, and the bars touch. So which set of data about a painting is qualitative and which is quantitative? So set number one, blue-green color, gold frame, smells old and musty, textures show brush strokes of oil paint, and it's a peaceful scene of the country. So does that deal with numbers or does that deal with describing it? Well, it deals with describing it, so that's going to be qualitative. Okay, set two. Picture is 10 by 14 with a frame that's 14 by 18. It weighs 8.5 pounds. The surface area of the painting is 140 square inches, and it costs $300. All of that has to do with quantities, it's measurements, so that's going to be quantitative. So on the back, we have describing the shape and spread of the data. Data sets can be compared by examining the differences and similarities between the measures of shape, center, and spread. So what are the measures of center? That's going to be your mean and your median. Sometimes they denote mean by an X with a line over it, and that's called X bar. When we used to use the actual calculators, you can see it when we're using these, but because we're not really using these right now, we're trying to use the Desmos. You won't see X bar as much, but just know that's what that means. These measures describe the expected value of the data. So what are the measures of spread? Well, there's the MAD, which we haven't learned yet, but that means mean absolute deviation. And that describes the range of the data with respect to the mean. So we'll talk about this in a couple days. The IQR describes the range of the middle 50% of the data. So the IQR is the middle 50%, that's the box of your box and whisker plot. So remember, IQR is the Q3 minus the Q1. And like we just said, if you have a box and whisker plot, this right here, the box is the IQR. The shape of the data can be seen by looking at the shape of the data graphically, symmetry, number of peaks, and uniformity. So if we look at symmetrical, concentrated towards the center of the range of the data is the same on both sides. So we're going to draw a picture. So we're going to draw our hill. It's actually called a bell curve, and it's going to be the same on both sides. That also means that right here in the middle, the mean and the median are both directly in the middle. They're at the same exact value. These lines should be touching. I didn't do a very good job. Okay, so when it's symmetrical, the mean and the median are both in the middle. If it's skewed right, it means it's concentrated towards the lower range of the data. The data will have a tail to the right. So when we do this one, it's going to look more like that. There's going to be a tail to the right side. So over here is the tail at the right. So what that means is your median is still in the middle. Let me make that green so it matches. So your median is still in the middle of your hill, but your mean, because there's higher numbers to the right are bigger numbers, your mean gets pulled that way. So your mean is to the right of the median. And how you can figure out if it's skewed right or left is, remember, it has to do with the tail. So if you think of your little, you can draw a little dinosaur. And if you give him a tail, his tail is on the right side. So that's how I always remember it. Draw a little dinosaur. Okay, next we have skewed left. So concentrated towards the upper range of the data. The data has the tail to the left. So now it's going to look more like that. So again, here's your tail. Tail is at the left side. And again, if you're not sure, draw your little dinosaur. So his tail is on the left. Okay, so remember, the median stays in the middle. But now we have the numbers being pulled to the left because that's where your tail is. So your mean is going to be the left of your median. So remember, your mean is your average of numbers. So if you have more big numbers, it's going to be pulled to the big.
Please come to attendance.
And if you have smaller numbers, your mean is going to be pulled to the left side, which means it's a smaller number than the median. Okay, the last thing we have for these notes is the number of peaks. So unimodal, think a unicycle. There's one wheel on a unicycle. So there's going to be one clear peak on a unimodal graph. Bimodal, like a bicycle, has two clear peaks. And uniformity has 0 clear peaks. So what does that look like if we look at like a histogram like we made yesterday? So you're going to have one peak in the middle, and then it's going to go down on each side. So one clear highest point. Bimodal has 2 high points. So if I do two high points, they're the exact same height, then the other stuff around it will look like that. So you have two clear peaks. If it's uniformity, that means that all of the bars are the same height. The data is equally spread. They're just all the same height.